Hi everybody, welcome back to another My Tutor online school tutorial. Today on GCSE Maths, fractions, and we'll be covering some ratio and percentages questions to do with that as well. So this session is 1 hour long, so it'll finish at 3 p.m. And it's led by me, Molly. I am a computer science and maths student at the University of Bath in my second year, and I've done over 150 lessons with my tutor, I think over 200 now, exciting. So yeah, I'll be taking this lesson. As always, if you're new, I think a lot of you have been here before. Pop messages in the chat and the Q&A throughout. I'm check them as I'm going. So if it's, could you quickly re-explain that? Go back to this slide, slow down, speed up, whatever it is, go for it. And then the final 15 minutes, I kind of stop like teaching, as it were, and take a Q&A. So if people want me to go back to a question at the beginning or have questions about something that I've done, and so on. So yeah, it's just gone 2. There's a few people in, so we'll get started. Okie dokie. So the structure of this lesson is going to be, I'm going to start by doing how we work with fractions. So adding them, subtracting them, multiplying, dividing them. And then kind of the second half is going to be, I've got a lot of problems here, so to do with ratios and percentages with fractions. So some really good, I think, interesting word problems that we can get stuck into. Cool. So to start with, it's like a mini little intro to fractions. If you've come to other ones, you'll notice that I always leave answers as fractions rather than decimals. And that's because fractions are so much easier to work with. Because if we have decimals can be recurring, decimals can be difficult to multiply and divide. As you'll see tomorrow, actually, we'll be doing some work with decimals. So little teaser trailer. So fractions are always nicer to leave them in. And you'll see why, hopefully, once we've done some like multiplication and division of them, that they're so much nicer than it would be if we had a horrible decimal. So we're going to start off by doing addition and subtraction of fractions. So this you've probably been doing for a while, especially if you're like GCSE, like years 10 or 11, but it's always good to have a quick refresher. So let's say we have 2/3 plus 4/5. The key to adding fractions is that we always want the denominators to be the same, because once the denominator is the same, I kind of imagine like smushing them together. So you just add the tops then. And that makes sense, right? Because again, if you've come before, you'll know that whenever I talk about fractions, I talk about a cake. If I have 1/5 of that cake and my brother has another 1/5 of that cake, then we've had 2/5 of that cake in total. So you can kind of see how it's really easy to add the fractions as long as you've got the same base, as long as we're talking about the same kind of amount. So what we do here is we've basically find, it sounds really fancy, but we find the lowest common multiple of these two. All that means is the smallest number that both of them go into. It doesn't have to be the smallest, it just makes it easier for us. So in this case, it's 15, right? 3 goes into 15, 5 goes into 15. So we make them both fractions that are over 15. Now with a fraction, we're allowed to multiply the top and the bottom by the same thing. And the reason is that what we're going to do is make this 15. And to make the bottom 15, we times it by 5. So we're going to do the same to the top. And the reason is because if we multiply something by 5 over 5, well, 5 over 5 is just 1. And you're allowed to multiply a fraction by 1 and it doesn't change at all. So that's the reason we're allowed to do this. And you'll see in a moment when we talk about multiplication, this means that we just multiply this and this. So all it really is you just multiply the top and the bottom by 5. So this becomes 10 over 15. And then we're going to do a really similar thing here. We think, how do we make the bottom of this be 15? Well, we times it by 3. So we do the same to the top as well. And again, we're multiplying by 3 over 3, which is 1. And you're allowed to multiply a fraction by 1. That doesn't change it at all. So this becomes 12 over 15. And now that we've got these, well, if you've got 10 15ths and you've got 12 15ths, then that equals 22 15ths. So what I've done here is I've just taken the top numbers and added them. As I said before, if you just imagine having like a fifth and a fifth, it's 2/5. You don't add the bottoms as well or anything like that. We get them the same and kind of overlap them and add those top bits together. And this can't be simplified anymore. We will be talking in a bit about simplifying fractions as well. But this can't be simplified anymore. So that's our solution. So 2/3 plus 4/5 is 22 over 15. Yeah, so that's just a kind of way of adding fractions. I'll do one more. So let's do 1/6 plus 3/4. Let's do that. So for this one, your instinct might be to put these over 24, because obviously we can times this by 4 and this by 6. So if in doubt, you can just do whatever the product of these is. However, if we do that, that's going to be quite big numbers, you know. Well, not that big in the scheme of things, but basically we can make it simpler for ourselves. We could make both of these be 12, because 6 goes into 12 and 4 goes into 12. So it's just kind of about being like smart and sneaky and seeing what numbers you can do to make these work. Again, it doesn't matter. If you can't see it and you just make them both equal 24, you will get the same answer. So we take a 6th and we want it to be something over 12. So we have to times it by 2. So we also times the top by 2. Then we take 3/4 and we want that to be something over 12. So we've times the bottom by 3. So we also times the top by 3. And then this will be something altogether over 12, and we find that just by adding the top numbers. So that's 2 plus 9, which is 11. So a 6th and 3/4 is 11/12. And then with subtraction, it's exactly the same idea. So let's say we have 5/6 minus 1/5. Now the smallest thing that both of these go into is actually going to be 30. So we do have to use that kind of bigger number. But we do exactly the same thing. So we want them both to go over 30. So we take 5/6. Well, to get from 6 to 30, we've multiplied by 5. So we do the same thing on the top, multiply it by 5. And then we subtract whatever 1/5 is expressed as over 30. So to get from 5 to 30, we multiplied by 6. So we do the same on the top, 1 times 6. And then we do this here. So again, we know that the whole thing is going to be something over 30. And to find that, we just do this, 25 minus 6. So that's 19. So 5/6 minus a 5th is 19 over 30. So hopefully that makes sense. Someone asked a good question here. When we have this answer, 22 over 15, we can write it as a mixed number. Yeah, that's exactly right. It just depends what the question's asking for. Top-heavy fractions are a lot easier. Like, say you had to go on and do more stuff with this number, you know, subtract something else from it or add it to something else. We always want top-heavy. But mixed fractions are a lot easier to understand, because we know that if it's, say, 3.5, it's 3 and a bit. Or if it's, you know, 7 and a 12th, we know that it's 7 and a bit, which is a lot easier to understand. So the way that we do this is we see, we basically split it up into, we kind of split it up again, like into 15/15ths and 7/15ths. So you can see that's the same thing, because it's just 15 and the 7. And then this one's 1. So it's 1 and 7/15ths, which I guess, yeah, is a lot easier to think about than 22 over 15. We know this is about 1.5. So hopefully that makes sense. Cool. Yeah, and I guess we can think about that as well, actually. If, say, we have to add well, there's a couple of ways that you can do it, I suppose. If we have to add 2 3/5 and 1 1/3, because this is kind of like saying 2 plus 3/5 plus 1 plus 1/3, you can actually just add these numbers and then add the fractions. So hopefully that kind of makes sense. However, I think if they're subtracted, you have to make them into top-heavy fractions first. Let me just have a think. So 2 minus... I think you have to make them into top-heavy fractions first there. I would always advise doing that anyway to make sure that you don't make any mistakes with it or like miss any terms. For example, this one would become... So if you make this into a top-heavy fraction, you basically see, well, what's 2 as something over 5? It's 10 over 5. So this becomes 13 over 5. Again, the way that I've done that, I'll just write it here in case anyone's confused. I basically said, well, 2 is like 10 over 5. So 2 and 3/5 is like 10 over 5 and 3 plus 3/5, which is 13 over 5. And then similarly, 1 1/3 becomes 4/3. Oh, sorry, I meant minus here, didn't I? And then we want to make the denominators the same, so this just becomes exactly the same thing. So we want to make the denominators 15. So this one we want to multiply by 3. So it becomes 39 over 15. And this one we want to multiply by 5. So it becomes 20 over 15. And then you just do exactly what we've been doing before. So 39 minus 20, that's 19. And if you want to, again, you can convert this back into a mixed fraction, which is 1 4/15. So yeah, I hope that makes sense. Yeah, perfect. And a lot of people were getting that, which is brilliant. Yeah, I forgot to say this at the beginning as well, actually. If you want to like try to work it out quicker than me and put the answer that you get on the chat, that's a really good thing to do, because then I can see that people are understanding, you can check your understanding, and also if you get something that's slightly wrong, I can tell you where you've gone wrong and help you with that. Okay, awesome. So now let's talk about multiplying fractions. So multiplying fractions is super, super easy, because let's say we have something like, oh gosh, that's a thick pen, 2/3 times 4/7. All we do when we multiply is we multiply the top and we multiply the bottom. It's super, super easy. So the top becomes 2 times 4 and the bottom becomes 3 times 7. And it's as easy as that. You can literally do it in one line straight away. Yeah, brilliant. People were getting that in the chat straight away. So these are super, super easy to do. So let's think about some kind of tricks that we can do to make our multiplication a bit easier for us. Say we have something like 3 over 16 times 8 over 27. So I personally would not want to do 16 times 27, especially because this is going to be on a non-calculator paper, because otherwise you could just put it in your calculator, right? So what we've got to think about is that these things are going to be multiplied on the top and these things are going to be multiplied on the bottom. And you can like cancel them once we've got a fraction. So say we have, let me just pop this on here because we'll be talking about this. Say we have something like 15 over 25. The way that we simplify fractions is by seeing something that divides both the top and the bottom. So just like how before, when we were trying to get it to the common denominator, we multiplied both the top and the bottom by something. Now we divide the top and the bottom by something. So here 5 goes into each of them. So this is the same thing as 3 over 5. So what we can do then with this is think, well, we can cancel things either just like this, we can simplify these fractions, but these we can't simplify anymore. There's nothing that goes into both 3 and 16, and there's nothing that goes into both 8 and 27. So we can cancel diagonally, because it's not really diagonally, because what this will become is 3 times 8 over 16 times 27. So you're really, again, only cancelling top and bottom. Hopefully that makes sense. And if it doesn't, just remember that when you're multiplying things, you can cancel diagonally. So what I mean by this is, well, let's think of something that goes into both 8 and 16. Well, 8 itself goes into both of them. So what we can do is divide 8 and 16 by 8. And similarly, let's look at this diagonal. Well, we've got 3 and 27. Well, 3 goes into both of those. So let's divide 3 and 27 by 3. And now look what this has become. If we look at just the grey bits here, this has become a half times a ninth, which is a lot easier than doing 16 times 27. So this just becomes 1/18. So you can do these really nice tricks that make it so much easier for you to multiply them. Sorry, I'm just having a look at a message that someone's put. Yeah, so someone was saying for the negative one, the one that I did here, if it will let me click on this page, that you can do it bit by bit, which I think you can. I always prefer having them top heavy, but you can like do 2 minus 1 and this minus this. So yeah, it's personal preference. So yeah, hopefully this makes sense, and I'll give you another example of that. So let's say we have times 9 over okay, yeah, 6 over 36. No. Yeah, okay, we'll do that. Yeah, we're going to do this. Are we? No, we're not. It's quite difficult to think of them actually, so that there's not like, so that we do the type of cancelling that I want to happen. So this is going to be 9 over 10, and this is going to be 6 over 27. That works. Cool. Okay. So first of all, we look to see if we can do any cancelling here, which we can't, or maybe it was something that we've done some cancelling with and we've got down to this where we can't do anything else. Actually, we can with this one. We can see that 3 goes into both 6 and 27. So let's do that first. So that makes this one. So if we do that, divide both the top and the bottom by 3. So this becomes 2/9 times 9 over 10. And then let's see what we can do here. Well, we can't do anything else down, but we can do diagonally. So what goes into both 9 and 9? Well, 9 does. So we divide both of them by 9. Just get 1. And what goes into both 2 and 10? 2 does. So we divide them both by 2. And in fact, what we've ended up with here is 1 over 1 times 1 over 5. And that's just 1 times a fifth, so it's just a fifth. So you can see this diagonal cancelling makes it so much easier for us to see what's going on, and so much, like, I hate mental maths personally. So I much prefer this method of cancelling and making it easier before we actually do any of the work. So I'll just do one more example. Let's say we have 11 over 28 times, let's do 160 over 10 over 30. Like I said, it's weird to do them. Okay, here we go, perfect. So let's see what we can do here, because again, I don't want to do any of these. Well, 11 and 28, nothing divides both of those. 160 and 30, 10 divides both of those. So let's do that and simplify this one down. So we get 16 and 3. So now this has become 11 over 28 times 16 over 3. So now we can't simplify downwards anymore, so let's have a look diagonally. 16 and 28. Well, 4 goes into both of those. So let's do that. So this becomes 4, this becomes 7, because we've just divided them both by 4. And then 11 and 3, we can't do anything with that. So this has become 11 over 7 times 4 over 3, which is a lot nicer. And then this is just 44 over 21. See, I've just multiplied these. So instead of doing it with some horrible big numbers, we've just made two tiny little, we've just divided this one by 10 and then divided by diagonally by 4. Some really easy simplifications, and suddenly we've made it into something that's really, really nice to multiply. So hopefully that makes sense. Just shout if it doesn't. So now we're going to have a look at dividing fractions. So dividing fractions is a lot easier than it sounds. Oh yeah, and if people want to know what this is, sorry, is a mixed fraction. Just in case you're like practicing that yourself at home, this will be, well, how many times does this go into this? It's twice. So it's going to be 2 and 2 over 21. Just shout if that doesn't make sense how I did that. So let's have a go at dividing fractions. So let's say we have something like 3/5 divided by 2/9. All we do here is we flip the fraction on the right and make it multiplication. Now this is quite hard to explain kind of why this works, but I always think the simplest example that you can think of is if you're dividing something by a half. So say I have 8 divided by a half. So like we want to know how many halves go into it. It's going to be 16, right? Because if you think about 2 halves make up 1. So then it's that. And that's the same as if we'd multiplied it by 2, which is kind of you take a half and you flip it, that's 2. So if you ever get confused as to what to do, just kind of remember that basic example. Other than that, if you prefer just to like learn techniques and just apply them, just remember to flip it and make it a multiplication. So this becomes 3/5 times 9 over 2. You see, all I've done is I've changed the divide into a times, and I've changed 2 over 9 to 9 over 2. And now, suddenly, we're in a case of multiplication again. And we know exactly how to multiply. Let's just check if we can simplify it all. No, we can't simplify any of these. So we just do 3 times 9 is 27. 5 times 2 is 10. Yeah, loads of people were getting that on the chat, so that's really, really good. Well done. And people were getting this right when we make this a mixed fraction. So this is 2 and 7/10. Brilliant, well done. So let's have a go at another example. Let's do 11 over 16 divided by, let's do 5 over 4. So what will this be? Remember, leave the first one. I think there's some mnemonic that people use to remember it, right? It's like leave, change, flip or something. I can't, let me know if yeah, but you like leave the first one, change the sign in the middle and flip this one. There's like something that people remember. And then let's just check if we can simplify this. So 11 over 16, no. 4 over 5, no. 11 over 5, no. But 4 over 16 we can, so let's make it easier for ourselves. They both are divisible by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So this becomes 11 over 4 times 1 over 5. And that's 11 over 20. And that's your answer. Brilliant. Lots of people getting it there. Someone said 11/8. Yeah, I think it was just accidentally. Yeah, that's the thing about writing it out enough, just in case you accidentally like simplify one of these but not the other one. So I'd always encourage you to write out as many steps as you need to. Okay, brilliant. So I think that's kind of as much as I hopefully need to cover on addition, subtraction, multiplication, and division. There we go. Someone told me keep, change, flip. There you go. So you keep the first one, change the sign, and flip the last one. Keep, change, flip. Thank you. So yeah, let me know if you want me to come back to it. But what I'm going to do now is just work through some word problems. Oh, okay. Someone's asked to do one more example. One more example of division with simplification. I think so. So that's what I'll do before I move on. So let's do, yeah, division. Okay, cool. Let's do, oh gosh, 20/13 divided by 35/3. So let's see what we can do here. Remember, keep, change, flip. So keep the first one exactly as it is. Change the sign to a multiplication and flip the final fraction. So keep, change, flip. Now let's see if we can simplify this. 20/13, no. 3/35, no. So let's look diagonally. 20 and 35. Yes, those are both divisible by 5. So let's divide both of them by 5. So this one becomes 4. This one becomes 7. 3 and 13, no, we can't do that. So this just becomes 4/13 times 3/7. And then we just do this multiplication. So 3 times 4 is 12. 13 times 7 is 91. That one you might want to do column multiplication for. That is still quite a good one. Okie doke. And yeah, this isn't top heavy, so we don't need to write it as a mixed fraction. So someone, yeah, a couple of people got it really well. Someone got 11/91. I don't know if that was a typo or, yeah, accidentally doing one. I think that the key thing to remember is to simplify it, because otherwise you can make really easy mistakes. Because if you didn't simplify it, this would be like 60 over, gosh, whatever on earth those two multiplied is. And then you'd have to simplify it down to this, and you would eventually get it, but without a calculator, that's very difficult. Okay, yeah, brilliant. Everyone got 12/91 for that. So I hope that makes sense. And I think throughout these, we'll be doing like, we'll keep working with fractions in these word problems. So hopefully we get some good practice. I can always come back to them at the end as well. So this first one, so we have actually done ratios before in one of these sessions. So that's not what this is about. This is about a kind of fractional way of thinking about ratios, if that makes sense. So this is kind of the most basic one that you get. So in a bag, there are blue sweets and red sweets, and the ratio of blue to red is 5/3. So what that means is that for every 5 blue sweets, we have 3 red sweets. So that means if we look at this image, how many are there total here? There are 8. And how many of those are blue? 5 of them. So it's as easy as that. What fraction of the sweets are blue? 5/8. And you can think about it, even if, because there probably aren't just 8 sweets, maybe there are 16 sweets and 10 are blue and 6 are red. Well, it's still the same fraction, because 10/16 is still 5/8. So that's why we're allowed to write it as a fraction, because it doesn't then matter what the total number is. So each of these blue dots could represent, each of these dots could represent 10 sweets or 12 sweets or 5 sweets and so on. But the point is that the fraction between them remains the same. So hopefully that makes sense why we're allowed to do that. Okay, someone said, could you quickly recap ratios? I won't go too much into it because we won't need it for this, but I guess this is the main thing to think about in terms of that, is we always think about ratios in terms of chunks. That was kind of the main way that I described it in the ratios webinar. So we think about the ratio is 5:3. So for every 5 piles of blue sweets, there are 3 equal sized piles of red sweets. So we kind of think about splitting it up into these chunks. So if the question here said let's say it said there are 40 sweets in total, how many are blue? Well, we see that there are 8 chunks total. So if there are 40 sweets, each of these chunks is equal to 5 sweets. So each of these dots here represents 5 sweets. So then how many blue sweets would there be? 5 times 5, 25, which we can see is also 5/8 of 40. So that's a really brief recap on ratios. Yeah, I'm going to do loads more. Someone's asked for another word problem on ratio. There's going to be loads more. That's pretty much so the next 15 minutes will be that, and then it'll be a Q&A. So let's have a look at this one. So again, a similar question. Help us think about ratio a bit more again as well. So in a bag, there are blue sweets, red sweets, and green sweets. And the ratio of blue to red to green is 5:3:2. So all this means is that for every 5 blue sweets, there are 3 red sweets and also 2 green sweets. So there could be 10 blue, 6 red, and 4 green. There could be 50 blue and 30 red and 20 green. All the ratio means, ratios and fractions are so linked, because all we're thinking about is not the overall number, just what fraction, what amount, what chunk of it is it. So again, we've got, so for every 5 sweets, so again, these dots could represent any number. We have 3 red and 2 green. So how many are there total there? There are 10. And 2 of them are green. So it's 2/10. And remember, we can simplify this. What 2 and 10 both divisible by? 2. So love that, getting an email from mathematics today during a maths webinar. Great. So they're both divisible by 2. So 1 and 5. So the answer is 1/5. 2/10 is also an acceptable answer, but normally they'll want you to simplify it, especially in an exam. Yeah, brilliant. And I think everybody got that. Brilliant. Well done. So let's have a look at kind of the opposite way of thinking about it now, which is saying we're given a fraction and we want to kind of derive the ratio from that. So in a bag, there are red and yellow sweets, and 2/3 of the sweets are red. And we want to know what the ratio of red sweets to yellow sweets is. So the way that I would think about this is we're going to want to draw 3 sweets total, and 2 of them are red. So if we have 2 red sweets, to make that up total, another 1 must be yellow. What have we got here? 2 and 1. So it's 2:1. Yeah, brilliant. People got that straight away. Fantastic. So it's just the kind of opposite process of before. This time we wanted to add up to be 3. Cool. So I hope that makes sense. We'll have a go at another one. Let's do this one. So in a bag, there are only blue sweets and green sweets. 5/6 of them are green. What's the ratio of blue to green? So green, 5/6 of them are green. So we'll do 5 green ones. And that means to make it up to 6, 1 of them's blue. So that's 1 there and 5 then. the reason that I've written them this way around is because we want the ratio of blue to green. So we want the blue on the left. So it's 1 to 5. So not 5 to 1. Yeah. Yeah, I think everybody got 5 to 1. Brilliant. Okay, cool. Let's have a go at some more difficult ones. So let's have a look here. So in a cinema, the ratio of adults to children are 3 to 1. And the ratio of boys to girls, so of the children, the ratio is 3 to 2. And we want to know what fraction of all the people in the cinema are girls. So this is quite difficult because we've got a fraction, like a ratio within a ratio. So the way that we're going to do this is we're going to think about it like this. So let's first of all think about adults to children. If we've got 3 adults here, we've got 1 child here. But we want to split these children into the ratio 3 to 2. So we want to be able to split this into 5. So instead of drawing 3 to 1, why don't we write this as 15 to 5? Just like a fraction, I can multiply both bits of the ratio by the same thing. I've just done 3 to 5. And the reason is because then this 5 can be split into this ratio, 3 to 2. So we can write it like this, 15 to 3 to 2. And what these parts mean is this is adults, this is boys, this is girls. So hopefully that makes sense. I've kind of made it into a 3-part ratio by multiplying this by something and kind of smushing them together. So then what fraction of all the people in the cinema are girls? Well, this fraction represents now all of the people in the cinema. So it's 15 plus 3 plus 2, so 20. Obviously, there could be 40 people in the cinema or 60 or 80 or so on, but it's going to be some multiple of 20. So out of 20 people, 2 of them are girls. And again, we can simplify this to 1/10. So our fraction is a 10th. So that's quite a confusing one. So well done if you understood that. I'll be going over more like this one, don't worry. So let's do this one. So on a school trip, the ratio of staff to students is 1 to 10. So again, what this means is that for every 10 students, there's 1 staff member. So if there are 30 students, there are 3 staff members and so on. So all the students are either year 7 or 8. The ratio of year 7 students to year 8 students are 3 to 2. So what fraction of all people on the trip are year 7 students? So now we're kind of thinking about it the other way because we want to make this so students is 10, but these add up to 5. So what we want to do is fiddle around with these until they add up to 10 so that we can kind of whack it in here, right? So why don't we instead write this as 6 to 4? It's the same ratio because we've multiplied both parts by 2. But now it adds up to 10. So we can take this ratio here, 1 to 10, and instead write it as 1 to 6 to 4. And this represents staff to year 7 to year 8. So what fraction of all the people on the trip are year 7 students? Well, let's count up how many are here. That's 11, 1 plus 6 plus 4. And 6 of them are the year 7 students. So it's 6/11ths. Yeah, loads of people got that. So that's really, really good. Because these are quite tricky, kind of thinking about how we can play around with them to combine the ratios. Let's do this one. I know it's the same as kind of the cinema ones, but the numbers are different. So it's good. So this time, this is they say theatre here and then cinema here. Oh well. So the ratio of adults to children is 7 to 3, and the ratio of boys to girls in the children is 3 to 2. So here we're going to have to kind of play around even more. So we've got 5 children here to somehow fit into this 3 part. So it's really similar kind of instinctively to how the fractions were. If we had, say, 1 over 3 and 1 over 5, we'd put them both over 15 to combine them. So that's what we're going to do here. We're going to make this number 15, and we're going to make these add up to 15. So let's start with the 7 to 3. How do we make the number on the right 15? We multiply it by 5. So this is the same thing as 35 to 15. Just multiply both bits by 5. It's exactly the same fraction. And then how do we make this one add up to 15 so that we can kind of replace this 15 by some ratio that tells us the boys to girls? Well, currently it adds up to 5, so let's multiply it by 3. So that gives us 9 to 6. Again, it's exactly the same ratio. We're just doing exactly the same thing. Sorry, someone said a few minutes ago, would you be able to explain how you did that, please? I think it was about one of these questions, so hopefully it's making a bit more sense now. Somebody said, what leveled ratio fractions and decimals be on OCR exams? I'm really not sure, I'm afraid. It depends on the question. These questions, I would say, are about a level 7, kind of maybe even level 8 question. They said, what if they're tricking you and the answer is 0? The answer will only ever be 0 if the ratio is like, you mean in this question, because it's what percentage in the cinema are girls. In an exam, I always assume that they're not tricking you, like in this. That's a good point though. Okay, so now we can combine these, and we can write the whole thing as 35 to 9 to 6. So I'm just going to try to kind of, I'll just write out what these are. So these are adults to boys to girls. And just to kind of explain myself a bit further, the reason that I did this was because we want to somehow, because this is adults to children, and then this is further down breaking up the ratio of the children, we want to kind of put this ratio in place of this 3. But we can only do that if it's kind of, again, like if the dots match up, because if we have 3 dots here and 5 dots total here, you can't just put them in place. Whereas if we change the ratios so that they're like this, we've got 15 dots here and 15 dots to replace them with. So all we're really doing is taking 35 to 15 and splitting up this 15 even further. So hopefully that makes a bit more sense. Hopefully, I'm not sure. Yeah, in this case, it's asking for a percentage. So we're kind of introducing the percentages part here. So what we're going to do is, first of all, start by doing it as a fraction. So as a fraction, well, let's see how many people are here total. 35 plus 9 plus 6, that gives us 50. And 6 of them are girls. So we get 6 over 50. So that's it as a fraction. Let's think about what it is as a percentage. Well, a really neat trick from converting, so I actually did do a lesson as well on converting between fractions, decimals, and percentages. So feel free to check that out for a more in-depth kind of look at it. But if we're converting from fractions to percentages, a really neat way, if we can, is just to express it as something over 100. Because as soon as it's something over 100, that top number is the percentage. So for example, 36% is 36 over 100. And 10% is 10 over 100. So here we've got 6 over 50. We can really easily get that bottom, the denominator, to be 100 if we just multiply the top and the bottom by 2. So this is 12 over 100, which is 12%. So just from these seemingly kind of non-linked ratios, we've worked out what percentage of all of the people are girls, which I think is cool, personally. Yeah, brilliant. Loads of people got that. Well done. Brilliant. People are saying it makes sense as well, and they get it. Fantastic. Okay. Let's do another one here. Oh yeah, okay. I've got time for this one, and then I'll open it up to like a Q&A. So start asking questions while I'm going through this question. Pop some questions on the chat. So it can again be stuff about like, what level is this? Would this be in an exam? Can we do another question like this one? Can you re-explain this question? please do ask those questions, because otherwise I don't know what kind of information you want to hear. So in a company, the ratio of men to women is 2 to 3, and 30% of the women are under the age of 30. So what fraction of all the people in the company are women under the age of 30? So I think this is quite confusing to understand at first because of all the words in it. But it's not really too much different from before. We've got 2 bits of information. We need to somehow link them. So here's how I would think of it. So we've got this ratio 2 to 3 of men to women. And we want to somehow think about what like 30% of this is. So if we want to think about 30%, let's first of all express that as a fraction so that we can then express it as a ratio and combine them. So there are a couple of ways to do this, and I'll go through both methods for you. So 30%, it's 30 over 100 or 3/10. So we know that as a ratio, that would be 3 to 7. Hopefully that makes sense. So the ratio of women to men is 3 to 7. And here the ratio of, sorry, I don't mean that. I mean the ratio of under 30 to over 30 women is 3 to 7. So this is women and this bit's women. So we want to make these the same to combine them. So this is 10 total dots, if we think about it like that. This is only 3. So why don't we make them both be 30 so that we can do it? So this one is going to become, currently adds up to 10. So to make it add up to 30, we multiply by 3. And this one is currently 3. So to make it 30, we times it by 10. So all I've done here is I've multiplied, I've made this one add up to 30 and this one be 30 so that I can combine the women into the women part. So hopefully it'll make sense once I write it out as a whole, which is 20 to 9 to 21. And what these mean is that this one here is men, this one here is women under 30, and this one here is women not under 30. So then what we're looking for in the answer is women under 30, which is this one. So let's see how many people are total here. 50, 20 plus 9 plus 21. And 9 of them are women under 30. So it's 9 out of 50. So hopefully that makes some sense. Yeah, brilliant. 9 out of 50 people were getting that perfectly. Well done. Okay. And I will show you the other method that you could do this by. So I'll just print the question again. So the way that we're going to think about it now, if you understood that other method, you don't have to listen to this if you don't want to be confused, but it just depends which you find simpler. So we're going to think about it in terms of like a percentage of a percentage this time. So in a company, the ratio of, or rather a fraction of a fraction, I suppose. So the ratio of men to women is 2 to 3. So what fraction are women? 3 over 5. Right, that's just like the questions we were doing at the beginning. There are 5 here total, 3 of them are women, so 3/5 are women. And then 30% of those are under the age of 30. So whenever we hear of, that means multiply. So 30%, or as we discussed, 3/10 of the 3/5 of the whole company are under the age of women under the age of 30. So 3/5 times 3/10. And what this means is like 3/10 of 3/5, because 3/10 of the 3/5 are women under the age of 30. And then we just multiply these fractions just like we were doing at the beginning, and you get 9 over 50. So I don't know which method people prefer. Let me know, because this one looks a bit more complicated, but I think it's possibly easier to think about. Like this might be quite complicated to think about, but it's easier maths. So yeah, it depends what you prefer. Yeah, someone said they prefer the first one. I think I probably prefer the first one, because I think once you see it as a whole ratio, we haven't really had to do too much fiddling around at all to think about this. I don't know. It's completely up to you. Both of the methods work. Both of the methods will get you full marks. So completely up to you. Okay, cool. So we've got 10 minutes left. So I haven't so far got any other questions. So what would people like me to go over? I can do some more of these. There aren't any more that I haven't really done on here, but I could maybe try some of these graph ones if people want to do those, or I could do more questions like at the end with percentages and stuff. Okay, cool. Someone said another one like this. Sure thing. Someone said maths jokes coming at the end. And someone else said ratio questions. Sure. So I'll do another one like this, and I'll just go through it using that first method. So I'm going to have to come up with a question now, seeing as I've exhausted all of the ones on there. So hopefully the numbers aren't too horrible. So let's go back to talking about beads, right? So the ratio of red beads to blue beads is, let's say, 4 to 5. And 20% of the red beads are spotty. Let's say what percentage of the total beads are red and spotty? So hopefully you can see that this is the same as the previous question. We've got a fraction and then like a percentage of one of the parts, sorry, a ratio, and then a percentage of one of the parts of the ratio. So let's think about this the same way that we did before. So the first thing that we want to do is express 20% as a ratio. So we can do that really nicely. So first of all, what is it? A fraction? Easy, that's 2/10. So the ratio of spotty beads to non-spotty beads, 2/10 as well, that's the same as 1/5. So the ratio of spotty beads to non-spotty beads will be 1 to 4. Right, that's just converting this fraction to a ratio, because we've got 1 out of every 5 is spotty, the other 4 are not spotty. So now we've converted this nicely to a ratio. And now let's have a look. Well, this 4 here represents the red beads, and so does this whole thing. So we want to kind of put this ratio in that place. But this is a 4, and we've got 5 total dots here. So let's make them both be 20 so that we can combine these together. So how do we make the 4 here 20? We've multiplied it by 5. So we'll just make this ratio 20 to 25. And we want to make this total thing add up to 20 so that we can whack it in the place of this 20 here. So currently adds up to 5, so we'll multiply it all by 4. So this becomes 4 to 16. So now we can see, because this is red beads to blue beads, and this is all about the red beads, we can just lift that red beads bit and put it in the place of this about the red beads. So again, hopefully it kind of all comes together once we see what it looks like in total. So 4 to 16 to 25. And what does this represent? It represents red spotty to red not spotty to blue. And hopefully you can see where I've got all of that from. Again, it's not too much working. We've just taken the ratio of red to blue and then taken the ratio describing the red ones itself and put it in the place here. So we've got red spotty, red not spotty, blue. So now what percentage of the total beads are red and spotty? So that's this 4 here. So what's it out of? It's out of 4 plus 16 plus 25 is 45. And it's 4 out of that 45. And now the question asks us for what that is as a percentage. So this is a bit of a trickier one to work out as a percentage, because again, we want to get this bottom bit over 100, right? But we can't just multiply the 45 by something to make it 100. So I have chosen quite a tricky one for this, but we can definitely do it. So the way that we do this is, first of all, we divide by something to like make this something that is a multiple of 100. For example, if we divide this by 9, if we divide the top and the bottom by 9, we get 5 on the bottom, which is a multiple of a factor of 100. So we can quite easily multiply that there. So what we get is, don't bother doing it as decimal. The top is just going to be whatever 4 divided by 9 is over 5. And then how do we work out that as a over 100? Well, now we can do this because 5s into 100 go 20 times. So we multiply the top and the bottom by 20. Now 4/9 times 20, this is another kind of note on fractions. We imagine it as being 20 over 1, because that is what the number 20 is. It's just 20 divided by 1. So we'll multiply the top and the bottom. So this becomes 80 over 9. So that's what it is. It's 80 over 9%, which you can either use a calculator for or say that's roughly equal to, because 81 over 9 is 9. So it's roughly equal to 9% of them are red and spotty. That's quite hard. I don't think you'd get, like, to be honest, this question would probably just ask you to leave it as a fraction if it was this difficult to make into a percentage. But yeah, well done. Yeah, people were getting that. So well done, because I accidentally made that really horrible, but hopefully you still managed to follow it. As I said, if this was a question, I think they'd just ask you to leave it as a fraction. Man, I received so many jokes today for the end, so that's exciting to pick it. Okay, cool. So I think we've just got 3 minutes left. So I'll just finish off with, let me see if I can find one of these that I haven't already done. Maybe one that I skipped past. Oh wow, did I really do all of these? Yeah, I think I pretty much did do all of them. So I'll just come up with one to do in the last couple of minutes. We'll do slightly simpler one so that we can do it a bit quicker. We'll say the ratio of red to yellow, oh my gosh, I can't type today, beads is 3 to 4. The let's say 10%, is that going to work? No, 20. I've got to try to make sure that this works. Half of the beads. Oh, let's just try this. Half of the red beads are spotty. How many are red and spotty? Let's try it. Maybe it won't work. Oh, rather than how many, what fraction are red and spotty? So let's do this again. So red to yellow beads is 3 to 4. So half of the red beads, let's express that as a ratio. So half of the red beads being spotty, it hasn't quite worked very well, means that it will be a ratio of 1 to 1, so spotty to not spotty. So we want to make this, so this 3 here is for the red beads, as is this. So this currently adds up to 2, so let's make them 6. So I'm kind of racing through this, but it's because it's the same as the other ones that we've done. So this will be multiplying by 2, 6 to 8, and then making this one equal 6, 3 to 3. This is talking about the red beads. This is talking about the red beads. So we just pop it in its place. So the whole thing becomes 3 to 3 to 8. So that's spotty, red and spotty, red and not spotty, yellow. So the one that we're looking for is red and spotty. So that's 3 out of a total of 14. So that was just a really quick final similar question. Yeah, that people got. Oh my God, there's so many jokes coming in as well for the end. Right, perfect. We finished with 1 minute to spare. The joke to finish off, because 2 different people sent it to me and I love it. What do you call dudes who love maths? Algebros. Cool. Thank you, everybody.
Amazing. Thank you very much, Molly, and thank you all for joining us. Remember that all of our sessions are recorded and you can catch them on our YouTube channel. Also, if you'd like more personalised one-on-one tuition, we do offer that. You can find out a bit more about that on our site. Thanks all. Have a lovely day. Goodbye.
Thank you guys. Bye.